You're listening to Casting Class, an engineer's guide to manufacturing aluminum castings, hosted by Batesville Products. For over 75 years, Batesville Products has been engineering, casting, machining, inspecting, and polishing aluminum castings for over 70 industries nationwide. In today's episode, we'll continue to share our experience and industry secrets. Casting Class is in session. First and foremost, I want to welcome everybody and our guests here today on the 5 critical elements to consider when machining aluminum castings. Let's go ahead and introduce our 2 guests today. Tim Weber, he's the bicycle enthusiast, and he's back for a 5th time here. And then we have Jim Whitaker. So a lot of you hopping on from Texas. Jim actually just got back from a fishing trip down there where they caught over 1,000 fish. Right, Jim?
Yeah.
You've been machining a long time. How many years have you been machining casting?
30 years.
Is that right?
Yep.
Wow.
Well, actually, I went through a program through high school. I signed up, and when I graduated, I started.
Man.
Actually, the next day.
Is that right?
Yeah.
Jeez, Pete.
So a lot of experience from both these guys here in the machining and the casting industry. With that, I'll go ahead and hand it over to you guys.
How critical is the material condition, the heat treat part of it? Walk through that a little bit.
Yeah, for us, when we get the casting down, we need the casting to be straight, check for flatness, certain flashes.
But some parts run through here unheat treated, some run through T6, some through T5. What's the difference?
Yeah, the difference is 356 cast aluminum unheat treated. Guys say, well, this thing kind of machine's gummy, which it kind of does. And it might change a little bit of your choices of tooling, because when you cut it, you might not see that shiny look like you would machining a piece of billet, 6061. Now, there's a cost associated going to T6. It's kind of my favorite.
Right. Because why? What happens with T6? What's it look like?
It's a darker color. It's actually a lot stronger.
Right.
But the machining, the thread quality, the finish, surface finishes, they're just easier to achieve.
So you in the past have talked about chips. I'm assuming if it's gummy, it's not chips. What? Tell me about that.
Well, it is chips, and it kind of comes off more like you would think is like a tearing effect.
Okay.
But there's a lot of good tooling out there that when we got to do something that isn't heat treated, PCD diamond, maybe roll form threading. Right. Instead of cut tap threading. There's methods for cutting it, no doubt, because the customer might not want to.
There's some parts that can't be heat treated because they just turn into a pretzel, There's no doubt about that.
Yeah, the physical strength or the structure of the part definitely becomes a trick for heat treat.
Tim, actually, before you go forward there, so I had a really good question come in from Rachel. So if a part's slightly warped before T6 heat treat, is it still machinable? And if so, what are some options or routes that you go through? Sorry, I said Tim, like Jim to answer this. How do you go about fixing that? And if it's not, how do you go about preventing that going forward?
Yeah, it's a real good question, actually, because, Tim had mentioned about, when you go to heat treat, you got to be careful because you do risk more of a warpage, or, we've even paid for heat treating to go through a straightening process. If it's a T6 part, it probably has to go back to the heat treater to be annealed, and then the straightness worked out, because you can't hardly move it once it's T6'd. I mean, you take the chance of cracking it. Yeah. If it's a T5, you can still bring that casting right back to form.
Well, I'm sure when you're mounting it up to the machine, there's ways around mounting a T6 and getting it into the shape that you wanted to machine it. But ultimately, what you're going to see when you pull it off the machine is that part's going to flex back. And you may have got the machining right, but the part still isn't hitting the end function and features.
Yeah, you're just chasing your tail because it's not going to meet the print. Obviously, if you clamp it and you think you got it all clamped up and the machine's fine, when you release it, then it's just going to twang right out of spec.
Something I was just thinking about. So when you're machining it, do you ever release tensions? And let's say it comes in dead nuts, square. You machine it, does it release tensions? Does it move sometimes after you machine it?
Sure. We try to use the 3.1 system as the gospel for datum system.
Which is what?
Well, you got a plane. We use a plane and we use a 3-point system. And then we got 2 points, which is the B, and then you got a C point. And if you can hold a part pretty neutral when you're machining it, even if you want to qualify the part before the next operations, then you'll probably have a success story. So, you can't clamp it in a distorted fashion and then expect to have a good part at the end of the day.
So the key is to bring that part in, the casting in, ready to go. So
yeah.
I know you guys trade back and forth with the foundry, straightening fixtures or templates that you can see if it is square.
If you're going to take a casting right out of the mold and not do any kind of heat treatment to it at all, you might take a chance if it's kind of a thicker part and a bigger part, where once you get done machining it, you'll see that thing kind of stress relieve. We use a T5 a lot to stress relieve it. Cost is less than T6. Plus, when you get done machining it, it doesn't want to release those, twangs on you, if you want to call it that, distortions.